of my concerns camping in a small camper van like this is managing moisture. I want to make sure I don't collect a lot of moisture in the van from cooking, from just breathing and perspiration. So I've got two strategies for that. One, I've ordered a diesel heater. It'll be coming here in the next couple of weeks. And I'll configure that so it'll heat up the cabin through the front window. There'll be a separate video on that in a few weeks. The second part of my strategy is ventilation fans. So I'm going to build a ventilation system that will work with these windows I have here in the Mitsubishi Delica. Like a lot of minivans, the Mitsubishi Delica has these little fold-out windows. They only open about 1 inch, which does not provide a lot of natural air ventilation. So I'm going to make a fan system that will force air through this gap. So here's what I designed up. I've built a plenum system around 2 USB fans. The fans will draw air from the van interior and exhaust it out these narrowed plenums, which will feed through the window openings. It's all constructed from acrylic sheets, which I can cut with a laser in the maker space at the local library. The fans I selected are from AC Infinity. They are intended to sit on top of and cool stereos and video equipment in home entertainment cabinets, so they are designed to be quiet. They run on 5-volt USB power and only draw about 1 watt. With each fan drawing 35 cubic feet per minute, the pair should exchange the air in my van about every 3 to 4 minutes. And so with my vector graphics files, I'm ready to laser cut the plastic. Some of the acrylic sheets are 6 millimeters thick to provide structure, while other sheets are only 2 millimeters thick to minimize how much plastic is taking up space in the narrow window opening. I've put a material list and CAD model down in the description below. The fans arrived in good order. Another cool thing about them is they have an extra female USB port, allowing me to daisy chain them together in series, so I can run both fans from just one USB power supply. They also have a built-in switch with 3 speed options. The main plastic sheet needed to be bent to the curvature of the window, about 1/4 inch, or about the same as the diameter of a pencil. So with a pencil and a heat gun, I formed the plastic plenum assembly to fit the window. After giving everything a coat of paint, it is time to assemble the fan and secure the wiring. And here's the final result, running on a USB power supply. With both fans on high, it draws 1/3 of an amp at 5 volts, or 1.7 watts. With both fans on low, the system draws about half that. And here's how it fits in the van. Finally, it's time to test it in the field with a winter camping trip to the Olympic rainforest. All right, it's 2 o'clock in the morning and I'm about ready to turn on my ventilation fan to see if it really makes any difference or not. So right now inside the van it's 42 degrees and 90% humidity, and outside it's 38 degrees and 99% humidity. So that's not actually a big difference, so I'm gonna go ahead and turn this on anyway, see what happens. What I think will happen is that we'll just take some of that outside air and bring it and mix it in more with the inside air, and the temperature inside the van will go down and the humidity will go up. And I don't know if that's going to make a difference or not in like condensation. I think it'll make a little bit of a difference because it'll be colder in here, and it's, it's the warmer air striking the window, the cold window of the van, that creates the condensation. So if it's colder air, then that should be at less effect. Anyway, let's go ahead and see if it really makes a difference or not. I'm going to go ahead and turn this on to a medium, and we'll see what happens. Right now it says it's drawing 1 watt, so pretty low power consumption, and the noise is very acceptable, very low the motor noise. Okay, let's see what happens. Well, here are the final results in the morning. As expected, not much really happened. The temperature and humidity difference between inside and outside were negligible. My thinking is that the ventilation fan would generally help to keep the inside conditions more similar to the outside conditions. But in this particular case, both inside and outside conditions were already very high in relative humidity, and so there just wasn't much room to make significant improvements by ventilation. I think where the ventilation fan really comes into play is when there's a potential for inside humidity to be higher than outside humidity, such as if I bring a lot of moisture into the van with me on wet clothes or if I cook inside the van. This would cause raised humidity inside the van, which the fan would ventilate to the outside. And with the fan keeping the inside and outside temperatures similar, window condensation should be reduced. In fact, here's what the windows look like the morning after the ventilation fan was used. Just a light fog. In my next video, we will add a diesel heater to the mix, which I expect will significantly reduce inside humidity and prevent condensation. So stay tuned for that. If you find this helpful, be sure to check out my Delica van conversion playlist.